it's KP to Math G. This is the month of December. We are getting very, very close to Christmas. But anyway, I found time to do a video, and I'm going to do one. I'm going to talk about a little bit of integration by substitution, and we're going to deal with part 2. And what I mean, we're going to do probably about 4 parts of this. Each segment of integration by substitution is going to get a little more and a little more involved. So a little more difficulty level at each time. So, but this should be fairly easy to do. Let me get my list of problems. Excuse me, sorry. All right, I think I have about 5 or 6 lessons already piled up, not just by substitution but by other things as well. But separation of variables will be the next thing that we do, but we're going to do at least 2 more parts of this substitution. All right, and again, just hang in there. It's going to be all right, because you're dealing with KP, the Math G. All right, so let's go ahead. When do we use substitution? So we're going to try this problem here. I'm going to integrate sine. All right, usually, I usually use x, but sometimes we use theta, so be aware of that. Alright, now we know that the antiderivative of sine is negative cosine, but we got a 3 theta here. So we got to do something about that. It would be nice if this were just theta. Well, we're going to do a little substitution here. So we're going to let u be that 3 theta. It doesn't matter what you have here. I could have had something like tangent of 1/8 theta here, all right, d theta. Then in this case, I'm going to let u be equal to 1/8 theta. That's what I'm going to do. All right, but we're not doing that particular one, but just kind of get the idea. If you see that, that's what you're going to do. All right, so, all right. Now, if this is just sine and it's sine and there's no cosine involved here, if it's sine and cosine together, we're going to let u be the whole thing. All right. All right, so that's how we do that. All right, and I keep saying I'm going to glue this magnet down in here. I've got a magnet that keeps coming out right here in this eraser. But anyway, I don't know if it'll stick after that. Nope, it won't stick, and it fell under the bed. So I'll just use this cloth. All right, on we go then. Let's do this. Then du is equal to 3. Now remember, if you take this is treated like it's a variable. All right, so 3 d theta, just like that. All right, I want d theta by itself. I've got d theta right here, so I want d theta by itself. So I'm going to multiply by 1/3 on both sides. All right, so 1/3 du. And notice what happens here. The 3's will divide out, and I just have d theta. And that's what I wanted to get down to, just that. So now I've got u being 3 theta, so I'm just going to put u in place of 3 theta. All right, so sine of u, and I don't guess I need a parentheses around that. So let's go ahead and just do that. Sine of u du. Now I know what that is. Okay. The antiderivative of sine is negative cosine. So this is equal to negative cosine u plus c, and forget your plus c on the end of it. But now we're not done, because u is 3 theta, so really we're saying therefore this is negative cosine of 3 theta. Now that's it. Okay. We just substituted 3 theta back into u. We want it back in terms of theta. Temporarily, we are putting it in terms of u. Okay. So that's, that's that problem there. Okay. Let me flip the board over. I might erase this, but I think we can do another problem here. Ooh, let's see here. Oh, I got Christmas stuff back here in the back. Hold on, let me move the boxes. Excuse me. Okay, boxes, you're going to have to move out of the way. Was not aware of that. Apologize. Alright, we're just going to have to move this over a little. There we go. And move it back so that you can see. Alright. Example 2. I'm all crimped up in here, y'all. Please understand. I'm really in a bind here, but we get through it. Alright, now here we go again. The antiderivative of the cube root of tangent. I guess we'll get x this time. Okay, and dx on the end right here. Sorry, that's not correct. It is secant. Excuse me. Secant squared. Secant squared x dx. Now, unlike that first one, that was just sine of 3 theta. This is tangent and secant, isn't it? Okay. Now, which one to let u? Well, if I see a radical here like this, u is going to be tangent x. Okay. Alright, so let's rewrite this first of all. I'm going to write tangent x. Now remember, this exponent is a 1 right here. So the index is 1 over 3. Alright, secant squared x dx. Think about this, guys and girls. The antiderivative, the derivative rather of tangent is secant squared. Okay? So I want u to be that. Anytime I have a radical, most likely you're going to let u be this right here. Alright, so let's do that. Let u be equal to tangent x. Alright? Then du is equal to secant squared x dx. Like that. Okay? We just happen to know that if I take the derivative of tangent, I'm going to get secant squared x. Okay? And then dx here. See, I have all of this right here. Alright? U is tangent x, so here's what I've got. In substitution, I've got u to the 1/3 du. All of that is du. Du is secant squared x dx. I know how to do this. You do too, right? Alright, so I'm going to add 1. Remember, u to the 1/3. Add 1. Now, the way I do it, I add 1 to it. That's 1 1/3, but you can also do 3/3. And make this u to the 4/3. Alright? So now this is equal to u to the 4/3 And the way I do, you know, you usually put over whatever this exponent is. If it's a fraction, you just flip it over like this, and you come out real nicely with 3/4. And then plus c on the end like that. Okay? But now we are dealing with tangent. U is tangent x. So we have 3/4. Okay. Let's see. Tangent x to 3/4 plus c. And here it is. Oh, to the 4/3, my bad. Well, when I saw this was the same as this, that's incorrect. So you just rewrite it as is, but the only thing is you substitute this back into u back, whatever u was, tangent x. U is tangent x. Alright. Now you have to know that the antiderivative, or the derivative rather, of tangent is secant squared. And that helps you understand what to do here. Let me erase this and give you 1/3 one. And I've been dealing primarily with the trig functions, and I'm going to stick with those. Bear with me while I erase this. Okay, alright. One more example. This is the final one. Alright, now let's integrate this. Okay, like that. Okay. Well, what to let u be? Let's figure it out. What do you say we try to figure this out? Now, I have not integrated this one in a while, but it's okay. We can do this. Let's rewrite it. Alright, cosine x over sine. I want you to understand that you can put the whole thing to that 4th power right there. Alright, you see that? And if you have a denominator right here, okay, well, there's a rule that says 1 over a to the n. Let's see, okay, is a to the negative n. And I'm saying that n is a positive number. It's greater than 0. Okay, it's not negative, in other words. So this is going to become negative up here like this. It's scooting it up this way. So let's rewrite it again. This is going to be, one more time, sine x to the negative 4th power cosine x dx. It would be nice if we could get that cosine x dx. And so I want you to understand that as we let u, we had the square root or the cube root of tangent a while ago, and when we let u be underneath whatever's underneath the radical. Well, here we're going to let u be what's associated with this exponent right here. Now keep in mind, I pulled this up right here. I put it up here, and this 4 became negative up here. And there's no, the denominator is just 1. Okay? Alright, let's go ahead and do this. Okay, let u be equal to sine x. Then du is equal to cosine x dx. Derivative of sine, I want to say is, yes, cosine. The antiderivative of sine is negative cosine. Okay? The derivative of cosine is negative sine. Okay? So kind of keep all those signs, S-I-G-N-S, straight in your mind. We have du right here. I'm going to put that right here. That's going to be, let's put this here. Well, here's du right here. That's all that. U is sine x, but that's u to the negative fourth. Can't leave off our exponent. We've got to still have that, don't we? Alright, so u to the negative fourth. Okay, so let me see here. Remember that when we took the antiderivative, okay, remember that instead of subtracting 1, we add 1. So now this is negative 3 over negative 3 plus c. I don't know if some people don't wait until later to put the plus c at the end, but I'm going to do it. That way I don't forget it. Okay. Alright, now u is sine x, isn't it? Alright, so sine x. I'll let u be sine x. Sine x to the negative 3 over negative 3 plus c. I can fix this up. Remember that if I have a to the negative n, that's 1 over a to the positive n. Okay, like that. Okay. So I'm just going to move this because this exponent is negative. This is not an exponent, so I'm not moving this up. Some students do that. This is not an exponent. It's the negative 3. I'm going to move it down there with the negative 3. So right up here, I'm going to say, oh, well, 1 over negative 3, put that out in front of it, sine x to the positive 3 right here, plus c. You can put the 3 right in between that little x. Okay, well, let's leave it out here like this for right here on this problem. Then on the next, okay, so now 1 over negative 3 sine, here's the right way to, here's the way you write it in calculus, okay? Put that little 3 up between them. That's the same thing as this here. This is what we had right here, okay? That's what I did. I just rewrote it right here. Alright, so now plus c, and that's it right there. Okay? I can double check. Let me get my book here. But I do believe that I am correct. Excuse me just for a minute, just for a second. I have a book that has all the antiderivatives and derivatives. The derivative of sine is cosine. The derivative of tangent is secant squared. That's what we did on our last example. Just double checking here, but I was certain that I had that. Well, I just wanted to make sure. Well, I guess I wasn't 100% certain, but there again, you just have to memorize that the derivative of sine is cosine. The derivative of cosine is negative sine, but the antiderivative of sine is negative cosine. So you have to kind of think, okay, oh wait, all right. So, all right. So that is that, and so that's what we had to do here on this here. All right. So that is all that we have here. I may come up and do another lesson. I don't know if I'll have time to do one today, but I may do one maybe tomorrow. we'll do part 3, and I want to say there's part 4 too. So we just want to make sure that we understand how to do this by the substitution method. All right, well that's it. I'm KP the Math G. Don't forget now, if you to go ahead and hit the subscribe button. I've got a few people who have subscribed. I would like to have some more subscribers. But if you don't do it, it's okay. I understand. It's perfectly fine. Then if you want to comment, I have a comment section below the video. You can make a comment. So just whatever you want to comment, whether you say thank you, I appreciate you very much, or whether you say, hey, you could have done this and this and this, and as long as it helps me out, that's all that matters, because I'm here to help you out. Okay, KP the Math G signing off. Have a great day.